Hi, and welcome to Tom Kennedy Science, and I'm your host, Dr. Tom Kennedy. Now today is part 4 for a 5-part episode on what is science. Today we're going to talk about some terminology in science. I know, terminology, but sometimes it matters, right? We're going to learn what a scientific fact is, a law, a theory, and we kind of already know what a hypothesis is as well. But, we need to get these things down, right? I mean, there has been an attack on what is a basic fact in our society. And, if we come up with definitions of facts, we're a little bit harder to attack a fact. So, we got this health crisis, and, man, we got to know what a fact is. We got to know what a scientific law or a theory is. And, when we don't, bad things happen. So let's just go through some definitions. We got facts, laws, theories. What do these things mean? Okay, let's start with a fact. So a fact is something that actually exists or happens. And you can verify a fact based on repeatable observations or experiments. Fact: the sun rises in the east, it sets in the west. That's a fact. I mean, that's indisputable, right? I mean, we can actually watch the sun rise, watch the sun set, and even predict when it's going to happen next. This is a fact. It actually happens. The next one is, look at that beautiful planet. The Earth is round. I know, not everybody in our world thinks this. Weird. I can't imagine living in the world thinking the Earth is not round. Eratosthenes, 2,200 years ago, demonstrated the Earth is likely to be round. Ferdinand Magellan sailed his boat, well, he died, but his crew, all 13 that was left of them, made it back around the world, and they actually lost a day because, they went through the international date line. Yeah, right? So, and then now, today, I mean, we've had astronauts that have snapped photos of a round Earth. We know that the Earth is round. That is an indisputable fact, despite what some flat earthers think. And if you're in New Mexico, you can see that you're right about there. Okay, yeah, so we've got observations. Man, I don't know how to explain it. The Earth is round, right? This is not contested. Oh, evolution. It's a fact. Wait. Hold on. Haven't we been taught that evolution is a theory? It depends. We need to know what a fact is and a theory. A fact is something that actually exists or happens that we can observe or measure it or test for it. Okay. Evolution is defined as a species change over time. So you go back 16 million years ago, you'd find this land mammal living around water, and it eventually moved into the water, and its descendants over time changed into modern day whales. Species change over time. That is a fact. Species evolve. How do we know it's a fact? We can see it. We can watch species change over time. We've seen it actually happen. Now, of course, whales evolving from an ancestor that lived on land into a modern day whale, of course, took millions of years, which is much, much, much longer than our tiny little lifespan. So we don't see large evolutionary changes in our life. So it gets hard for people to understand like how old the Earth is and how long it can take species to change over time. But as our definition of evolution, we know that to be a fact because we can observe it. Here's another fact. Guess what? Vaccines work. I know. There's people out there that are so afraid of them, but they work. This is a chart showing measles cases from 1954 to 2008. Looking at this chart, can you guess about when the measles vaccination was invented and was at least introduced widespread? I can. Look at that, right in the 1960s. And then it just declined, and it was almost completely eradicated until some people decided that they didn't want to get the measles vaccination, and well, it's back on the rise again. Okay, now here's a problem that we have in our society. There's these things called alternative facts spread by fake news, and fake news, I hate to use that term, but some news programs don't know the difference between an opinion and a fact. There's no such thing as an alternative fact. I'm sorry. There's a fact that's verifiable, and you either verify it or you don't. Facts are verified. They are, if I find a fact, you can verify it too. And to deny a fact is basically you're denying reality. So, for example, we'll talk about this in chapter 12, but I'm going to talk about climate change at the end of the semester. We know that the burning of fossil fuels is rising surface temperatures. It's causing the surface temperatures to rise. It's also causing the oceans to rise as well. So we're getting higher sea levels. I mean, look at these dead pine trees. I mean, that is an effect of sea level rise, right? I mean, that's right where I grew up. I took this picture last week. Sea level rise is real. Warmer temperatures are real. We can directly measure this. And in fact, last year was tied for 2016 as the hottest year on record. But there's one enormous difference. 2016 was El Nino, which is a warming in the Pacific Ocean. 2020 was a La Nina, cooling in the Pacific Ocean. So despite a La Nina, we still tied for the hottest year on record. And we know that it's the burning of fossil fuels causing that. When we get to chapter 12, I'll have that chapter where you can read that. You will see that we know this based on enormous amounts of data. So that's real. Okay. Many people attended my inauguration, biggest one in the world. Okay, well, we can snap a photo of this is called the National Mall. One had about 900,000 people, one had 1.8 million people, one was larger than the other. There is no alternative way to spin that. That's a fact. I mean, that's not a photoshopped photo. I mean, that's an actual photo. Recently, there's a lot of conspiracy theories going on about stolen elections and voter fraud and voting counts. 306 to 232, the Electoral College count. This was based on people's votes. And in some, these votes represent a piece of data. And in Georgia, where somebody denied that they lost, in Georgia, they counted the votes by hand 3 times. That's like, I go out and I conduct an experiment and I collect all my data and I recount my data several times. And hey, sometimes you got to count the data twice or 3 times. It's okay. Especially when it's close. You got to make sure you get it right. But once you've verified that, you have a fact that one person got more votes than another person. This is an important point. I'm not trying to be political or make a political statement about science. I'm saying that the role of science can help us understand the world, and that we have to understand that facts are based on observations that are verifiable. Votes are verifiable. Votes can be considered factual. That's a problem when lies get spread throughout our society and people don't believe in facts anymore. That causes us problems. Okay, now let's talk about laws, because most people don't dispute laws. So Newton's law of gravity here. A law predicts the same outcome under the same circumstances. Newton's law of gravity. It says if I drop something, it will fall at the same rate anywhere on the earth every single time I drop it. And the rate of acceleration is 9.8 meters per second squared. So you drop your pin in Florida, you drop your pin in New Mexico, it's going to fall at the same rate every single time. So a law is telling you what's going to happen under the same circumstances. Now, a law does not propose a mechanism. Newton never explained how gravity works. Why does your pin fall to the earth? Why do we not get flung off into space? Well, that was the general theory of relativity that explained that in Einstein. Okay, so in biology, or actually in physics, I should say, there are these laws of thermodynamics. And the laws of thermodynamics, they explain how energy is transferred and transformed. Now, the reason why I already start with the first law of thermodynamics and the second law of thermodynamics here is because life needs energy. That's important. I mean, without energy, there is no life. So to understand the laws that govern energy transformations, well, as you can imagine, that is helpful for understanding how life works, right? The so the first law of thermodynamics, it basically says you can't create or destroy energy. You can transfer it and transform it. So if you're building a fire, the wood has energy stored in the wood. When you light a fire, you release that energy. You're transforming that energy from one form to another, and you're not losing or gaining any energy. The amount of energy before and after your reaction stays the same. You just transformed it from one type to another. That sounds awesome, doesn't it? I mean, here it is. We've got all this energy in the universe, but then let me see. Oh, but then we have that pesky second law of thermodynamics, and that says, every time you use energy, you degrade it. It becomes less available to do work. So even though you have all the energy the universe started with, as we continually use it, as we transfer it or transform it, it becomes less available to do work. And this thing called entropy increases. Entropy is, of course, a measure of disorder. And oh man, I'm telling you, disorder is a stable state. And that's where the universe wants to go. So every time we use energy, we're generating entropy in the universe. And I will talk much more about that in chapter 6. Now, let's talk about theory. You know, one of the greatest movies of all time, not my favorite, but one of the greatest. My favorite is, of course, Star Wars. But The Princess Bride, what a fantastic movie. And there's this character in here. He kept going, inconceivable, inconceivable. And finally, Niga Montoya goes, you keep using that word. I do not think it means what you think it means. That's theory. People use the word theory all the time. But the way that theory is used in everyday language is quite different than the way it's used in science. Imagine that, right? Imagine we use the word theory. Theory does not come lightly. You remember that law of gravity developed by Isaac Newton? He just described how it works, and somebody said, "Well, what's your laws of motion and your laws of gravity? Yeah. How does gravity work?" And Newton goes, "I don't know." That took a couple hundred years and one of the greatest intellectual leaps ever taken by a single individual, by Einstein, who came up with the general theory of relativity. A theory. And he said that gravity is caused by objects of mass warping space-time. Wow, the actual fabric of the universe is bent around objects. What is the theory of relativity? I mean, that's what it's saying. So what is a theory? A theory is a broad, powerful explanation for a set of observations. Now, importantly, theories have been well supported by observations and experiments, and they have yet to be refuted. Einstein's general theory of relativity that explains how gravity works has yet to be refuted, has yet to be disproven in over 105 years. And in fact, all of our experiments have verified his theory over and over and over again. Now, let's go back to evolution. Didn't I just say evolution was a fact? Yes. Species change over time. It's a fact. Just like you will fall to the earth. That is a fact. Why do species change over time? What causes species to change over time? What's my explanation? What's the why here? That is a theory of evolution by natural selection. People call it natural selection, evolution by natural selection, evolutionary theory. Explains how evolution works. It explains the observation that species change over time. We will discuss this much more in chapter 2 on themes in science. But basically, evolution by natural selection explains that, hey, there's lots of individuals born each year or in each generation. They're not all the same. The ones that are best fit to the environment are best likely to survive. Pass on those genes to the next generation, and over time, your population changes. It explains why species change over time. And like Einstein's general theory of relativity, it has been supported by almost 170, 160 years of evidence from both observations and experiments. It is yet to be refuted. And in fact, evolution by natural selection is so important that it's the central paradigm of biology. And we're the only field, scientific field, that has our central paradigm routinely questioned by the general public. But evolution by natural selection is really cool, right? It says, hey, we're evolving over time. We share common ancestry. What does that mean? Well, look at that whale skeleton, right? Does it look familiar? You got some vertebrae, you got some ribs, you got a scapula, humerus, radius, ulna, phalanges. Yeah, that's that front fin. It's even got the same number of neck vertebrae as you and I do. Why? We shared common ancestry and it changed over time through natural selection. Awesome. Okay. So let's do some metacognition here. How well did you understand facts, laws, and theories? This is important because if you're not understanding this very well, you need to go back. A fact, something we can verify. And science does prove facts. That much is certain. Science supports theories. We don't actually prove theories, we support them. And this idea that, oh, it's just a theory, we don't really know. No, that's not true at all. We know, and we know based on observations and experiments that we have verified that theory is indeed the explanation for how things work. That is important. Okay. Well, it's been another episode of Tom Kennedy's Science. And stay tuned for part 5, Critical Thinking.